0. Uh, so this should do tensor matmul backward, and should do tensor matmul backward, tensor x, tensor y current node. Tensor matmul backward and takes x, y, and current node, which is c. Yeah, so I think this should be like current node gradient, and this is also current node grid, right? And so we have x, y, and current node, and let's see what happens. Tensor matmul backward, I have void, conflicting types, void, tensor matmul backward, conflicting, tensor.h, tensor matmul backward, it should take tensor y and tensor current node, tensor dot c, tensor matmul, tensor matmul backward, am I importing tensor? Yeah, so let's just comment this out then, and let's see what happens. Undeclared. Okay. Matmul. One of tensor matmul. Okay. 34. Alright, so yeah, this is one thing. I need to pass arena as well. And the tensor matmul, there also need to pass a. Conflicting types, maximal backward. I should also take arena. Have initialized arena, yes. C. What's wrong here? In place. Ooh. 299 plus C. Tensor maximal backward. um Current node. We only need current node here. You don't need anything else. So in the forward pass, we only have info about the current node. In the backward pass, we only have this current node, not anything else. We can pull the parents from this current node, right? So okay, let's just see now. So we have tensor current node, and let's say it has only two parents. So tensor x would be something like uh, parents 0, like so. This is 1, right? So now everything works as it is. Tensor maximal, it takes arena, and should we pass arena? A, right? And if I go to tensor h, tensor.h, backward. Tensor maximal backward. Okay, like so. And if I do one more thing with tensor.h, and this op should be now what? It also takes arena A, because it uses tensor maximal operation which returns a new tensor. So we need to pass the arena over here in order to allocate the memory for that new tensor. And let us see if this works now. Tensor squared backward. this? Yeah. Let's say it takes arena as well. Okay. Too many arguments. Tensor might move backward. Okay. Tensor matmel assertion failed. Okay. Let's run one more time to get the exact error. So tensor slice columns backward. That there isn't any issue over here. These are all the warnings. Okay, we need to change the syntax, which we'll do later. So we're passing a greater number of arguments. We can fix that later, but right now the problem is this thing. Tensor matmel assertion failed. Okay, so where actually is this happening? So I think 707 right here. Tensor matmel assertion failed. And why is it happening? Let's just see. Tensor matmel backward, which takes A and Z. Which takes A and current node. And here we have what? So we have X and Y, and then we have Z, right? Z is equals to tensor matmel, print Z shape, tensor shape 2D Z. Let's see if we have Z. Something is wrong. Okay, so print F. Something is wrong at the first place with Z, I guess. Arena tensor, yeah. Assertion failed. Okay. What shape do we have for x? Yeah, so we need to take transpose. Oh man, so tensor y t would be tensor transpose y, and this should be y t. Now we're getting z shape, and if we just remove this exit, let us see what happens. Again, some problem. So printf z data, and this is going to be tensor get 2d z, and this is z grad data. um z grad undeclared. Okay, fine. Z grad, and okay, so we have all right, so we have z, and we have z data, all zeros. Fine. Makes sense. And then let's debug what actually is wrong with our method. So tensor matimal backward, so let's just go to matimal backward. Current node parents. Does z store parents? That's the question. This is getting interesting. So does z store parents? So let's just say print f z parents, and this should be z num parents. Oh, are you serious? Tensor matimal. Does it store parents info? Requires grad number of parents equals to arena lock parents A and B. Yes, this stores parents. Z should have parents. So I think Z num parents. Yeah, Z should have parents. This is also correct. Z parents. Z parents. Okay, so Z has parents. Uh, I mean, tensor matmul. Yeah. So A and B, and our out is like what? So our out is this, and need to save parents. Out parents equals to out parents. Yeah. So A and B. Out requires squared equals true. Why is it not printing the parents at the first place? Are you serious? Let me check again if the. Oh, I'm printing it wrong, man. Dude. One day you work on Python and the other day you just forget the syntax of C. So there's something wrong because it's not storing the parents. Tensor matimal. Are you serious? There's something wrong with the matimal operation in the first place because it's not storing the parents. It should store x and yt as parents, right? So now, see, now since we're digging deep inside the Autograd, so you have to check each and every tensor node, and you sort of have an idea that what actually is wrong with your logic underneath, right? So let's just see what's wrong over here. Okay, so it's not having the parents information, and the parents information can only be available when out requires grad. So out will only requires grad when A requires grad or B requires grad. So let's just do one thing. Wait a second. So let's just tensor dot h. Let's see the architecture. Let's see the structure of this thing. So where is requires grad? Uh, bool requires grad. Let's see if November operations requires grid. Okay, let's not do it like this. Tensor.h. Let's do it like this. So x requires grad equals true. Yt. Oh man, now we have two parents. Oh really? That's what we needed to do. Um, okay, so we're getting the shape of the parents, right? That's right. Yeah, so this is grid. Okay, so so we have parents, and then minimal backwards. So we obtain successfully x and y transpose, and what is dx?